Alright, boys and girls, welcome back to the drive-through for a 3-mix. We're going to go after this one more time and see if we can get it right, Marissa. Special shout-out to Marissa. Okay, so Lucy's now hearing this for the third time, so I apologize. But do you remember that, that first time where you ever thought to yourself, I think I might actually be smarter than this teacher? I'm sure you guys have thought that before. I'm sure most of you guys think that about me, which is true. But for this guy, Carl Gauss, it happened when he was super young, and I just remember that my high school math teacher told me this story, and I always really appreciated it. Carl, don't call me Ethan Gauss, was screwing around in class way back in like the 1400s or 1600s, whenever he lived. And his teacher was all salty at him and was like, go sit down in the corner. And then Gauss kept talking. So he said, hey, Carl, why don't you do me a favor and add up the first 100 numbers? He just gave him something to keep him busy. And Gauss sat there for maybe like 25, 30 seconds and was like, first 100 numbers. Oh, it's 5,050. And the teacher knew what the answer was. And he was like, that kid, that punk must have memorized that answer. What an idiot. So he said, okay, if you're so smart, why don't you add up the first 1,000 numbers? And very quickly, Gauss spat back the answer. I don't know. I think it's 500,500. And the teacher didn't even know if he was right or not. And this is the story of the sum of arithmetic series, okay? So we're going to show you how Gauss did that in his head here in just a second, but let's analyze these words. Sum means we're going to add things. Arithmetic means it's going to be in the form mx plus b, so it's growing by the same number every time. And series is the sum of a sequence. So up until now, we've just been looking at sequences, patterns, sets of numbers. Now we're going to be adding those up. So how did Gauss do it? How did he do 1 plus 2 plus 3 plus 4 plus 97 plus 98 plus 99 plus 100? How did he do that in his head so fast? Well, the trick is he didn't add, he multiplied. He thought to himself, what's 1 plus 100? 101. What's 2 plus 99? 101. What's 3 plus 98? 101. What's 4 plus 97? 101. So then Gauss goes, oh, I got this. There's going to be 50 pairs, and all of them are going to add up to 101. And indeed, you get 5050, 5050. Okay? So what if you added up 1, 2, 3, all the way to 1,000? Well, that's going to be 1,001 times 500. And indeed, whoa, ViewSonic. Indeed, that's 500,000. 500. Okay? So, to find the sum of an arithmetic series or sequence, okay, let a sub 1 be the first term, a sub n be the last term, and therefore n be the total number of terms. You take the number of terms, so the sum of the number of terms is half of the number of terms times the sum of the first one and the last one. So you're going to need to know that, but I wouldn't memorize it. Just understand or remember the story of Gauss. Don't call me Ethan Gauss. Okay? Alright, so now I think we know the difference between a sequence and a series. A series is a sum of a sequence. Okay, and is there any notation? Oh, is there ever? Okay, so this sigma sign means sum. Sigma is a letter. I think it's maybe Greek. Okay, so you're going to see this as the sum as n goes from 1 to 100 of n. This is the pattern we just described. This is 1 plus 2 plus 3 plus 100. That's exactly how we're going to write. So this right here is the same thing as that. Okay? Alright, I'm sure you're kind of bored and kind of confused, so let's go on to some examples. I mean, you could literally just add this. 1 plus 3 plus 5 plus 7 plus 9. Or you could say the sum is 10 times 5 over 2. And that's 25. So that one was easy. Number 1 is usually easy. Number 2 is not as easy because we don't know how many terms there are. So anytime this chapter I'm a little stuck, I'm going to make a T-chart. The first term is 5. The second term is 8, The third term is 11. So notice our slope is 3. What's our y-intercept? We'll go backwards. It's 2. So our equation here is y equals 3n plus 2. Alright, so let's go back and think about what the heck we're doing. I don't know how many terms there are. Which term is the 26th term? I know it's going to be n divided by 2 times 26. Well, here, let me do it in order, not confuse you guys. Times 5 plus 26. But I don't know which term 26 is. So let's just find it. 26 is 3 times n plus 2. 24 is 3n divided side by 3. Oh, it's the 8th term. It's the 8th term. So just to show you, it's 5, 8, 11. We're going up by 3 each time. 14, 17, 20, 23, and 26. We're adding all these up. And notice that 26 is indeed the 1, 2, 3, 4, 5, 6, 7, 8th term. So you'll do 8 divided by 2 times 31. 4 times 31. 124 is this answer. Okay? Let's do some more. So we know that a sub 1 is... Come on. Jeez, Pete, this is incredible. We know that a sub 1 is negative 20. We know that a sub n is negative 65, but we don't know how many numbers there were. So let's just find the equation. The first term is negative 20. Second term is negative 25. Third term is negative 30. So m is negative 5. Put in a 0. You get a negative 15. b is negative 15, so you get y equals negative 5n minus 15. We're trying to figure out which term negative 65 is. So you'll do negative 65 is negative 5n minus 15. Add 15 to both sides, and you get negative 50 is negative 5n. Divide each side by negative 5, and you get there's 10 numbers in this sequence. Okay? So, to find the sum, you would do 10, so S sub n is 10 divided by 2, the number of terms divided by 2, times the first one and the last one added together. Negative 85 times 5, and you're going to get negative 425 is the answer to that. Okay? Let's do 13 over here in red. Once again, we could just put this in our calculator, but wait till they get really big. You're going to need to know how to do them. First term is 15. Second term is 25. Third term is 35. Zeroth term will be 5. This is y equals 10 n plus 5. Okay. Which term is the 75th? So you get 70 is 10n, so n is 7. A sub 1 is 15. A sub n is 75. So you get, let's see, 7 divided by 2 times 15 plus 75. That's 90 times 3.5. And that's 315. Okay, moving on. Find the sum of each finite series. Okay? Alright, so all this means the first term, put in a 1 for n. You get 0. Second term is 1. Third term, 2. I'm putting n, and I'm getting the function there. Fourth term will be 3. Okay? So literally, I think we're just going to add these up, and the answer for this one is 6. Okay? But let's just get to the nitty-gritty. Because these, all we need is a sub 1 and a sub n and n. Well, a sub 1, put in a 2. 4 minus 1 is 3. A sub n, well, that's going to be a sub 6. That's our last one. N's going from 2 to 6. Okay? So our last one is going to be 12 minus 1, which is 11. Now, how many of these do we have? Ooh, let's see. We don't have 6. We started at 2. So let me just write them out real quick. The first term was 3. Second term, 5. Third term, 7. Fourth term, 9. Fifth term, 11. So since we didn't start at 1, there's only 5 terms in this sequence, okay? So the series total will be 5 divided by 2, 5 divided by 2, sorry, but the Wi-Fi is just terrible in here right now, times 3 plus 11. So that's 14 times 2.5, which is 35. Okay? So I think here, since n starts at 3 and goes to 8, there's going to be a total of 6 numbers. Okay? I think the first one is going to be 3 plus 25, which is 28. I think the last one is going to be 8 plus 25, which is 33. So for this one, the sum is going to be 6 divided by 2 times 28 plus 33. So that's 61 times 3, which is 183. Okay? Now, in the next section it says find the sum using your graphing calculator. I'm going to ask that you just Google that. Google how to use a TI-84 to find the sum of an arithmetic series. And now you're starting to take control of your own learning. Have a great day. Boom!